Right, this is a bit of a tricky one, especially as we're going to use a diagram to help to aid us. So the car is released from a rest position A. So we're going to call this position A there. And accelerates due to gravity down the track to position B. So it goes down the track to position B. Okay, now mass of the toy car is 0.04 kilograms, so we'll just do car, that can be the car, and it's 0.040 kilograms. Now remember, kilograms have to be kept as kilograms. It's just one of those things you need to remember. Remember on the sheet it says convert to this unless in kilograms. Okay, so we've got 0.040 kilograms. Vertical height between position A and position B is 90 centimeters. So 90 centimeters is one of those ones. Centi means for century. So that means to convert from century to meters, you need to divide by 100. And that will give us 0.9 meters. So when I first see FIFA, we need to remember that height is 0.9. So we do 90 divided by 100 equals 0.9 meters. So you just have to remember, for centimeters, divide by 100. Remember, centi means century. You should know that from maths anyway. Okay, so that's our first thing that we get the mark for. Now, we need to understand a bit of physics here. So we know that the car's got gravitational potential energy at the top, and as it goes down the track, all that gravitational potential energy has at the top is transferred into kinetic energy at the bottom, because we know as it slides down its height gets lower, so its gravitational potential goes down, but its kinetic energy goes up, okay, because it gets faster and faster as it goes down the track. Now it says calculate the maximum possible speed, so that just means ignore any air resistance or any friction that might slow it down. Okay, so because we've got gravitational potential energy at the top, the first thing we have to do is work out the gravitational potential energy at the top. Okay, so we need to find the equation with gravitational potential energy, and the key clue here is you've got gravitational field strength. Okay, is 9.8. So we're going to go down and we're going to look for gravitational potential energy. So if we go down, not that one, but we've got that one, and we're going to use that. EP, which is gravitational potential energy, equals mass times gravitational field strength times height. Now the clue should be that in the question it tells you what the mass is and it tells you what the height is. So it says the height is there and the mass is there. So you should be thinking, yeah, we've definitely got to use this formula. EP equals m times g times h, which is mass times gravitational field strength times height. Now, so what we're going to do now is replace the letters with numbers. Now, we don't know the gravitational potential energy, so we're going to leave that like that, but we do know the mass is 0.040, and we know the gravitational field strength is 9.8, and we know that the height is 0.9 meters. Okay, so we can actually work out our gravitational potential energy. We don't even need to rearrange, so we can work out that our gravitational potential energy equals that. So let's put that into our calculator. 0.040 times by 9.8 times by 0.9. That will give us 0.3528. Okay, so it's 0.3528. So this is what you need to remember. We've got 0.3528 joules of gravitational potential energy, or the car does at the top. Okay, now as it goes down the slope, its height decreases and it's basically zero at the bottom. So that energy has to go somewhere, so all of it is transferred to kinetic energy. So by the time it gets to the bottom, the kinetic energy is 0.3528. There's no gravitational potential energy left, so GPE equals 0. So all that gravitational potential energy it had up there is transferred to kinetic down here, which makes sense because its height has decreased as it's gone down, but its speed has increased. So now we know that the kinetic energy is 0.3528. So it's asked us to work out speed. Now, if we know the kinetic energy, which is EK, equals 0.3528, and we also know the mass equals 0.040, we should be able to find an equation that has speed in it, kinetic energy, and mass. So let's go down our list. Oh, look, we don't have to go very far. It's just there. We've got speed. That's what we're trying to work out. Okay. And we've got mass and we've got kinetic energy. The only hard thing here is knowing that if you're working out gravitational potential energy and something's going down the slope, then as it rolls down the slope, it gets faster and faster and faster, so the kinetic energy increases. Any question that's to do with rolling down the slope is always going to be to do with gravitational potential energy and kinetic. So let's see phi for it again. There. And we don't need to convert anything because we've got everything sorted. We're going to use that equation. EK equals half the mass times velocity squared, because that's what we've got the data for. Half mass times by velocity squared. Replace that with the numbers, so we know that EK is 0.3528, because that's the kinetic energy, equals half the mass, so half of 0.040 is 0.020, and times by v squared, which we're trying to work out. So let's rearrange that. Let's rewrite it over here just to make it easier. 28 equals 0.020, which remember is half the mass, times by v squared. You want to get v squared on its own, so we just divide by 0.020. Whatever we do to the right, we do to the left, so 0.020. Those cancel, so what we end up with is 0.3528 divided by 0.020 gives us our v squared. Okay, so if we put that into our calculator, we're dividing, so fraction button, we've got 0.3528 divided by 0.020 gives us this. So it's 17.64. Now that is the v squared. So what we want is the square root of 17.64. So square root of 17.64 gives us 4.2. Okay, so our answer is 4.2. Hopefully that makes sense.